Hello guys, hope all of you are doing great. This is part 8 of our 8086 programming tutorial. In this part of the video, we are going to learn about the concept of loop in 8086 programming. Now in 8086, there is a specific instruction called loop, and certainly we're going to learn about that instruction also. But in general, in this part of the video, we are going to learn about the concept of loop and how we can implement the concept of loop in in 8086. Maybe directly by using this loop instruction, or maybe indirectly by making use of some other known instructions. Like known in the sense like the instructions that we already have covered in this tutorial. So for example, compare, add, and a conditional jump like that. Okay, and let's say we want to write this hello world. We want to write this program. Like this will be our example program. At the end of the video, we will know how we can write the program that displays hello world 100 numbers of time on the screen. Okay, then let's begin. First, let me briefly explain you the concept of loop, and then I'll go and I'll write the code for the program. Let me use the syntax of a for loop to explain you the concept of a loop. So here I'm writing the syntax of a for loop that is used in most of the high-level programming languages like C or C++, C#, Java, PHP, JavaScript, like that. And the general syntax is a for loop contains three compartments here in this way, separated by two semicolons. And then associated with it is a body, okay, like this. This is the general syntax of writing a for loop. Now here, these compartments, usually what we write in this first compartment is a initialization statement, initialization of a counter, usually, okay, not always. You can write any valid expression here actually, but typically, okay. And then here, typically we execute a logical expression that what is a logical expression? It means the result of the expression is either true or false, only two possible outcomes. And then in third compartment, we typically do increment or decrement of the counter that we initialized here. And associated with it is this body. And this for loop, if you see here, how this for loop is actually executed by the computer. Okay, just one thing here. Whatever it is the instruction, obviously you are writing a program. It means there might be some instructions which are just before the for loop. So the last instruction just before the for loop, I'm writing here as begin. It means this is the last instruction, and after this instruction, immediately the control comes to execute the for loop. And then whatever it is the instruction just after the for loop, the first instruction, I'm denoting it as next. You see here, this begin and this next, these instructions are outside the loop. They are not part of the loop. Okay, so I'm writing them just to make the picture complete. But you should realize they are not part of the loop. Okay, then having said so, so we know, like, let me now draw the flow chart. I mean, how the computer is actually going to execute the loop. So say after executing the last instruction just before the for loop, that is your begin, it comes to execute the for loop. So when the control comes to execute the for loop, you can think the first part that will be executed is this initialization of the counter here. Initialization of the counter. So I'm writing here, say, initialization of the counter. And after that, the next thing that it will do is after executing this instruction, next thing it will do is it will execute this logical expression. So it will execute this logical expression. And I'm writing it in a diamond box just to indicate that there are two possible outcomes of this logical expression. Either it could be evaluated as true, or it might be evaluated as false. Now, after executing this logical expression, as we said, there are two possible outcomes, either true or false. Let's see what happens when the logical expression, the result of the logical expression is true. So if it is true, then what does it do? The control will reach inside the body. I mean, it will start executing the body here, body. Now, the thing is, this body is not a single instruction. It could contain multiple instructions. So in that case, what will happen is all these instructions will be executed one by one from top to bottom. Okay, like this, from top to bottom. And once that once the computer executes this last instruction inside this body, what will happen is the control will go to this point here. In this diagram it will be like this, and in this flow chart it will be, that is, after executing this last instruction, the control will see what it will do is it will execute this increment or decrement instruction. So increment or decrement instruction, basically it will execute whatever it is there in the third component of the loop here. Okay, and after that what we want is, after that this control will go back and it will check this logical expression, or it will evaluate this logical expression one more time. It means here in this flowchart where the control will go, the control will go back to this logical expression part again. So again, this logical expression will be evaluated. If it is true, again this loop will be evaluated. A loop will be executed for one more time. That we call as a another iteration of the loop. It means the body will be executed one more time, and one more time this increment decrement will happen, and again the control will reach back to this point. So this is a loop actually. You can see here in this picture, this is a loop. So in this picture, this is a loop. And up to what point this loop will be executed? As long as this logical expression is true, this loop will be executed. It is logical expression true, body evaluated, go back and increase, decrease, and then again logical expression. So at some point of time, this logical expression should become false. I'm saying should become false. It means what? It is, as a programmer, it is your responsibility to write the code in such a way that, at some point of time, this logical expression become false. Now, when it becomes false, then what will happen is, instead of taking this, true part, it will now take this false part, and it will take the control actually out of the loop. It means what? Whatever it is the instruction out of, just after the loop, that instruction will be executed. Now, see, it is just like, it is going out of the loop. Now, it is no longer, inside this loop thing. Okay, and in this picture it will look something like this. If it is true, then it will get inside the body and it will evaluate and it will follow this loop. But if it is false, then what will happen is the control will go back to, it will go out of the loop and it will reach here. So whatever the instructions are there after that point, it will follow this part here. So now that is the actually, like, that is how a loop works. Okay, so I just used the syntax of a for loop to demonstrate you, or to explain you, the concept of a loop. See here, you just think for a moment. I'm explaining you in the reverse direction in some sense, no? Like, see, if you think of the evolution of programming languages, then first it was machine level language, that is, codes were written in zeros and ones, and then they decided, okay, writing code in zeros and ones certainly difficult, so they used like some mnemonics, or some some set of words to them, to represent some specific instructions, that we call as assembly level programming language. And again, it turned out like writing code in assembly level language programming is certainly easier than writing code in machine level language. But again, they're not very much intuitive. Certain codes are very long, and they are difficult to debug and find the errors. Those sort of problems were there, and then they thought like, okay, why not write the code? Why not make the syntax of the code more closer to natural languages like English, or something like that. So from they invented, okay, now something called as high level programming languages, like, say, for example, C, very commonly used high level programming language. And then again, on top of C, other languages like C++ or maybe Java, and then she has all these different programming languages evolved. And if you see the syntax of other programming languages like Java, C has, and even C++, JavaScript, they are in many sense, they are similar to C programming language. Syntax means, say, for example, how do you write a for loop, how do you declare a variable, how do you initialize a variable, and all this stuff. So it means the evolution is from machine level language to assembly level language, and then high level programming language. But here, see, I'm explaining you the thing again from high level, with reference to a high level programming language concept. Then I'm trying to explain you the thing, and that's why these high level programming languages are very popular. Like why they are very much close to our intuition actually. Okay, but anyhow, that's a separate story. Now, once suppose, now let's come back to the point. Suppose now we have understood how a loop works. I mean, how different components means this is how we write a loop in high level programming language, and this is how the computer executes the loop. Um, Sort of, this is the flowchart, right? Now if we know how the computer executes the loop, then suppose now we have to implement this loop in an assembly programming language, then certainly we should be able to do it if we can implement these individual components, right? Now, if we ask ourselves now, do we really know how to implement these individual components in 8086? It means up to this point, whatever we have learned, based on that, can we write all these individual components? If you think for a moment, the result will come out as yes. Yes, we know. Initialization means what? Storing some initial value to a variable, maybe, or a count, or a register that we know. Like we can use move instruction. This logical expression is evaluated, and based on that, we sometimes want to, uh, execute a block of code, this block of code, and sometimes we might want to execute this block of code, right? And that is what? That is branching, using this jump condition and the conditional branching, right? So that already we have studied, so we know that thing also. And then this body part is nothing but it is the it is like they are set of instructions, valid set of instructions in that specific programming language. So they could be anything actually based on your task, so we more or less know like what we have to write. Like for simple task, at least we know. And then increment decrement is nothing but like adding. Increment means what? Adding one to a particular value. So we know, say for example, we want to increase the value of a register by 1. Then what we do, we can write, if we do not know any other thing, then simply we can write add ax comma 1. It will increase the value of the register ax by 1. So increment decrement also in some sense we know. It means we know like how to implement these different parts of the loop, and it means we should be able to write a the equivalent. I mean, we should be able to write a 8086 program to actually implement the concept explained by this flowchart. Okay, then let's try to do it uh, to write the program that I showed you in my first slide. And what was the program for? I mean, write a program to display hello world, say 100 numbers of times on the screen. That's our goal. Now see, display hello world, this part is actually the body. I choose the body in such a way that we know how to implement the body. Sometimes, uh, okay, I'll come to that point later on. But anyhow, my point here is, see here, display hello world is actually the body of the, should be the body of the loop here, because that is the thing that we want to repeatedly do 100 numbers of time. And this rest of the things we have to fill in such a way that, this task is done 100 numbers of time. Okay, let's try to do it. First, I'll do it in a flowchart, and then I'll write the actual code. You will come to know. Let me write it in this way. Say, for example, the begin as usual, that represents from whatever the instruction which is just before the for loop, and after that let me draw a blank for loop. What I mean by it, sorry, let me draw a blank loop. What I mean by it, just let me write the main blocks here. This is the initialization block, and then this is the condition that we want to check, and this is the body of the loop, and this is the increment decrement part of the loop, and then our control goes back to this point here. Our control goes back to this condition again, and if this condition is true, then obviously it will be repeating the loop, and if this condition is false, then it will be going out of the loop. Now what we have to do is we have to fill in these blanks, sort of, that so that this flowchart, uh, like at least theoretically displays this hello world 100 numbers of time on the screen. So for that reason, what we can do is, see, we can take many different approaches, but let me take it in this way. Say we set a initial counter, say for example cx, and we set it to, say for example 0. I'm writing cx equal to 0, and if the equivalent is move cx comma 0 in 8086 instruction. That's simple, right? And then I'll be writing here sort of, I'll not be writing exact 8086 instructions. I'll be writing like what exactly we want to do there, okay? And then we'll be writing the actual 8086 code. Don't you worry. Now cx is equal to 0. That's the first thing that we want to do. Say, and then what we might want to do here is we want to repeat these loops, say 100 numbers of time. So what condition we should check here? Say we are just assuming that we are starting from 0. We are starting from your cx is equal to 0, starting from here. And what condition we should write here so that this particular loop executes 100 numbers of time. Yeah, one condition we can check here is whether the value of cx is less than 100 or not. That's it. That is, our 100 is somewhere here. Here cx is equal to 100. And then you can see here, these steps are like one at a time. This is cx is equal to 0. This is cx is equal to 1, then 2, then 3, then 4, then 5, and up to this cx is equal to 100. This is cx is equal to 99. And as long as the value of cx is less than, in each step we'll be sorry, in each step we'll be moving one, we'll be jumping from here to here, then from here to here. There is no intermediate values in between these two numbers there, okay? So that way what will happen is when cx is equal to 0, we'll be displaying hello world here once. When it is 1, then also we'll be displaying it. Then also when it is 2, then also, like that up to 99 we'll be displaying every time one hello world. And then when it becomes 100, we'll stop the process. You can think it that way. So here you can write like cx is less than 100, right? Now if this condition is true, it means that if cx is anywhere somewhere here, like, then we might want to display hello world on the screen. So we'll be displaying hello world. As long as the value of cx is less than 100, we'll be displaying hello world on the screen. And after displaying, see here, suppose we displayed hello world here once, and after displaying hello world, what we want to do is we want to move to the next point, so that again in that point we can display hello world. So for that reason, what we have to do is we have to write here cx is equal to cx plus 1. Cx is equal to cx plus 1. And when this condition becomes false, we want to go out of the loop. Now you see here, if you follow this flowchart, then you should realize that, okay, we are starting cx is equal to 0, and then we are like checking if it is less than 100 or not. So certainly 0 not less than 100, it will display hello world on the screen. Increase it, then it will become 1. Then again it will go and check this condition whether it is less than 100 or not. Yes, it is. When it is 1, then also it will be less than 1. When it is 99, then also it will be less than 1. So that way 100 numbers of time it will display hello world. And when it becomes 100, then immediately it will become false and go out of the loop. Okay, now our next goal is to implement these while loop, sorry, to implement this for loop using 8086 instructions. That's what is our final task. And after that, we'll be talking about, okay, well, that's what our final task, okay, for the time being at least. Now, what do we have to do? We want to move cx comma 0. See here, our ultimate goal is to display hello world 100 numbers of time. It means we have to display a string. That's the the minimum task that we want to do. So for that reason, let's start with our common strategy that we want to display a string ultimately. So we'll be declaring a variable string, and there we'll be storing what string we want to display. So hello world, that's what we want to display, okay? And then we will be terminating it with this dollar symbol. That's all that I guess we need in the data segment. And see here, these counters, I can use variables, but we'll be using registers here, okay? So okay, done. So string, we have stored it. Whenever we need to display, we can now display string 1 on the screen. And after that, let's start from here. Cx is equal to 0. How do you do that? We'll be writing move cx comma 0. You might be asking, why did I use cx? Can I use any other register? Yes, certainly you can use any other register, but the thing is that, suppose for example you are using say ax register, you should always remember that ax might be used as a default storage for some other instruction, by the processor, microprocessor. So that might, you should be careful. As long as you are careful, then it's fine. But cx is commonly used as, as a counter, so that's why I'm using it. So move cx comma 0, so cx is initialized, and then we want to execute this compare instruction. I mean, we want to actually implement this part here. Okay, now it is not a single instruction. It could be a, set of instructions that ultimately gives you the effect of this branching. Okay, so let me do it in a particular way, and obviously there are different ways of doing the same thing. You can find out some different ways also, but here, just for demonstration, I'm using a, obviously I have to use one particular way only, right? So okay, for that reason, what we can do is we can compare. First thing is, blindly you can compare this thing with whatever the number that you want to compare. This number, actually, if it is 100, then you can write 100. Then what is next? How do we make use of this compare, the result of this compare instruction? If you remember from my previous video, now writing compare is not on, is not going to do anything in its, in its own. So we also have to use this conditional jumping instruction to implement this branching, right? So now let's see here. We have compare. Now when we want to do what? That is the question. Now if the value of this cx register is less than 100, then we want to execute the body of the loop. Yes. But if it is greater than, or you can say it in this way also, if the value of the cx register is greater than or equal to 100, it means this condition is false. Means when this condition is false, you can say false means here cx is greater than or equal to 100. This condition is true. Actually, this false is, for these conditions, true will lead you to the same point. These conditions, false, will lead you to the same point. You should comprehend that. Okay, so I'm going to actually make use of this thing to do the branching. That's why I said it is, but you can certainly think of other ways also. So what we want to do is, if the value of this cx is greater than or equal to 100, then we want to stop the process. So that's what we're going to do. Jump greater than or equal to. And again, why am I using jump greater than, not jump above? Just assuming that now I'm using unsigned numbers. But again, you can use jump above and equal also. Jump greater than or equal to. If it is greater than or equal to 100, we want to transfer the control to the next instruction. In our case, it is terminate the program. So I'll be writing here, terminate the program. Done. If it is this, then we want to terminate. If it is this, means ultimately this condition is false, we want to terminate the program. But if this condition is not false, it means this condition is true. I mean, this condition is not false means it is true. I mean, this condition is false this time. It means if this condition is false, then it will be skipped, and by default, the control will flow to the next instruction here. Okay, so what we want to do is, here actually we want to, as soon as this becomes true, it means we want to display hello world on the screen. So what we'll be doing is, here hello world we have to display on the screen. How do you do that? First, we have to load the effective address to the X register of what? String 1, and then we have to move the specific number 09H to AH register, and then we have to call this int21H. I mean, we have to execute this int21H instruction to call the interrupt service routine that displays the string on the screen. Done. After executing the body of the loop, what we want to do is we want to increase the counter by 1. So if you can do it in this way, add the value of the CX register by 1. Certainly you can do it in this way, but there is a direct instruction in 8086 that increase the value of its operand. So that instruction is increase, INC, increment, okay? And the name of the operand is here CX. That is, we want to increase the value of the CX register by 1. Done. This is done. Cx is equal to Cx plus 1, done. And after that, what we want to transfer the control back to this particular comparison instruction. See here, this is something as a programmer now we want to do. See, in high level programming language, when you write the code in this way, then it is automatically done. But in assembly code, when you are writing this, you are implementing a loop, at least in this way, then this transferring of the control you have to do by yourself. And for that reason, see here, after increasing it, we have to transfer the control to back to this point. And we know actually how to transfer control in 8086 just by writing. Now, here we do not have to check any condition. It is unconditional jump. That is, as soon as the control reaches here, reaches a, it executes. This is done. As soon as the control like reaches here, immediately it will go back to this point. So here, what we want to do is we want to transfer the control back to where this comparison instruction. So here. So for that reason, what we have to do is we have to give it a label. Say we are calling it say L1, and then from here we were transferring the control back to L1. It means the next instruction again after this immediately it will again check this condition whether Cx is equal. No, it will do a comparison Cx with 100, and after that it will check. This conditional jump instruction will be evaluated. I mean, when this conditional jump instruction will be true, it will be true if the value of the Cx register is greater than or equal to 100. And if it becomes greater than or equal to 100, what we want to do? We want to terminate the program actually. So we want our control to go back to this point. But if it is false, in that case, we want to get into the body of the loop and we want to execute this part. And after, sorry, we want to execute up. This is the up to these three lines are the body of the code. And then we want to increase the value of the Cx, I mean the counter. And then we want to transfer the control back to this point. That's what we're doing here. Okay, and again it will go back to this point, and again the same thing will be repeated. And at some point of time when this condition becomes false, jump greater than when this condition becomes true, jump greater than or equal becomes true, in that case the program will be terminated. That's all then, I guess. I mean, this program that see here, we just converted this flowchart to this program actually. Now, if we execute this program, we should get the output as expected. But let me use here a small number, say 10, so that we can count and verify the output. Okay. So this is the program. So instead of displaying it 100 numbers of time, it will be displaying it 10 times on the screen. Okay. Okay, then our program is written. Now we are ready to compile and execute the program. Oh, I stopped that. Sorry, I'm sorry. This thing. We have to start the tasm assembler, and there we have to compile it. So how do you do that? Tasm, just by writing, what is the name? pp10. Okay, tasm. I want both of them to be displayed. I sometimes find it find it difficult to move these things. Maybe some problem with my mouse. Okay, tasm pp10.asm. Done. Yeah, no error, no warning. So ready to link then pp10. Okay, and execute. Directly I'll be executing. You can execute it in debug mode and you can try to understand the flow of the program, but I leave that thing, as your own exercise. Okay, now see, the more effort you put in your exercise sessions, then more stronger your mental muscles will be. So it is up to you, okay, what you want to do. But here I am executing the program directly, and let's see whether we get the output as expected or not. Okay, we got hello world, hello world, hello world, quite a few numbers of time on the screen, but it's difficult to count them actually. I mean, they're coming just one after another. What if we want to display them line by line? I said most probably in one of my previous video. If you want to do that, see here, actually here what we have to do is we have to like in C what we want, in C how we can do that, just by writing a new line character, right? New line means bring the cursor to the beginning of the next line. But here we don't write new line in this way. Instead, what we want is we want to store the first 2 bytes as this 13, 10, and then the next bytes are like hello world, like that. You see here, it is still string one is still a an array of bytes. The first byte, the value of the first byte is 13, the value of the second byte is 10, and the value of the third byte is H. I mean the ASCII code of H. Then like that. Okay. Now see, this 13 and 10 combinedly they represent the new line character or the carrier's return. But ultimate effect is that it brings the cursor to the beginning of the next line. Let's recompile this program and execute this program. You see how the output will change. Okay, now see the output is changed now. Like each and every hello world is coming in a new line. And see here, there's this blank line. The first hello world is also coming in a new line, so that's why you're seeing this blank. And if you count hello world, 1 2 3 4 5 6 7 8 9 10, 10 numbers of time hello world is displayed. Now program is right, I guess. I mean, let me change this to another smaller number, say 3. So now if I compile this program, and I should get here as expected 3 times hello world, right? Right. Now if we want to display 100 numbers of time, no worry, this time just change the value of the counter, recompile the program, and done. Hello world. If you count, you will get 100 numbers of time. But I think that you got the point, right? Okay. Then this is the program actually, and this is how you can implement a loop in 8086 using 8086 programming instructions, 8086 instructions. Okay. Now, at the beginning of the beginning of the video, I said, okay, there is a specific instruction called loop that makes this process a bit simpler. Okay, and let's now see how we can write the same program using the loop instruction. Now it is time to talk about the specific loop instruction available in 8086 programming. Now it allows you to do the same thing, but in a sort of it's sort of a shortcut actually. Okay, so what you do is you have to first initialize this register CX. See here, now it is directly CX. You cannot use any other register. This loop instruction works with the CX register. So CX with some number like that, whatever the number, how many times you want to repeat the loop, whatever that number is. If it is 10, then you'll be writing, you'll be storing 10 to CX register. And then you will be writing the body of the loop, whatever it is, the set of instructions that you want to execute, you will be writing it. And that body, the first instruction, you have to give it a label, whatever the label that you want to call. And then you'll be using this loop instruction to go back to L1. Okay, now see here, this increment and decrement part is sort of implicit here. Basically what it will do is it will start with CX and it will repeat this loop. If you are using this loop instruction, it will repeat this loop as long as the counter is not 0, and in each iteration the value of the counter will be decreased by 1. So that way this body will be executed 10 numbers of time. Or you can think it in this way also, right? Just one mechanical way of interpreting this loop. What you can think of is, say for example, you have here a storage of fuel. I mean, that can actually, you can think of like it has some whole numbers of this volume of the fuel is whole numbers, say 1 liter, 2 liter, 3 liter. Just for simplicity I'm using it. Okay, so then what you have to do is you have a robot, and that you want that robot to, or you have a robotic car, or whatever the way you want to think, you have a device here or a mechanical device here that needs fuel to 1 unit of fuel to complete 1 round there. Okay, now every time that this robot starts its journey, the first thing is initially it's empty. The first thing that it will do is it will fill the fuel. I mean, it will fill its fuel tank and it will make it full actually. Okay, and once it fills this, I mean this particular unit is gone. Then next, so, and when it takes a round here, say halfway around here, half of the fuel will be over, and when it about to finish the loop, most of the fuels will be done. When it reaches this initial position, again it will be empty. So if it wants to start its journey again, and it actually does that as long as the fuels are there. Okay, so it will take the next unit of fuel, and then again it will continue the loop. Then it will take the next unit of fuel, again continue the loop. Next unit of fuel, continue the loop. Next unit of fuel, continue the loop. Next unit of fuel, continue the loop. And when it reaches like, okay, here again, that time it will realize, okay, no more fuels are there, so it will stop the loop and it will again fall back to its default execution. Can you comprehend that? You can think it that way also. That's how this loop instruction is going to work. Okay, now that's just an explanation. If you write the code, if we write the code as a computer science person, certainly sometimes we directly can understand things from the code, right? But then also just for those people who, I mean, I'm not saying those people are not from computer science background, but as a as a beginner, what I felt was initially, um, people, I actually learned programming. My initial programming thing I learned from my friends. My friends used to, I'm very much grateful to those friends. Let me mention a few names. One of my very good friend was Raka Day in my engineering time. I'm just telling you a story, true story. Raka Day, and he, when I was in my first year of engineering, I was not that good in. I was actually very new to, in fact, completely new to programming. But he studied programming in his class 10, I guess, or class 12, I guess, and he was very good in programming. And he was from, I guess, electrical engineering. I mean, he was about to study electrical engineering, but for the first and second semesters we had these common subjects. And then I realized, okay, this guy is very good in programming. And I went to him, I requested him. He said, no problem, I'll make you learn the programming language, don't worry. I mean, that time we were learning C programming language. And he used to explain me programming languages, I mean, using this sort of diagrams, this sort of, and some analogous example. Then slowly and slowly I realized, okay, now that's how things works. I found it very useful, this other way of explaining the concept. Okay, and one friend was Rakade, and the other friend is was my Varun Saikia. I said was because I lost my contacts with those people for, for many years. They are still there, certainly. I should have used is, my friend. Okay, I'm sorry. But anyhow, no, that's a thing. Now we are ready to write the code for this program. How we can actually write a 086 code to, like using this loop thing. So what I said is, the first thing that you have to do is you have to initialize this counter, or you have to initialize this fuel tank. How do you do that? So the counter is fixed CX. So you have to store there the initial value, whatever it is. And then you have to write the block of the code, but you have to give a name to the block of the code, the label. Here, I'm writing here L1 and then the block of the code. What code we want to write here as part of the body of the code? We want to display here the string. So we'll be writing load effective address to the X register, the string of the string S1. Done. And then we want to store this repeatedly we are writing for quite, now we are writing it very frequently, so you know what I have to do. AH of this, and sorry, and then int 21h, that's part of our body. And after that, simply loop to L1. See here, we don't have to actually decrease or increase the counter of the CX. Whatever it is the value, that many times this loop will be executed. Okay, so this way, this program should generate the same output as this program does. Okay, let's compile the program, check the output, run the program and check the output. So this time our program is pp11.asm and then plink pp11 and then directly pp11. Now see, this is displaying you hello world on the screen 10 times. Whatever that number is, that many times. If it is 100, then this program will display you 100 numbers of times hello world on the screen. If it is, say, 3, it will display you 3 times on the screen, right? Okay then. So these are two different ways of implementing a loop in 8086. See here, in this approach, in our previous approach, what we learned is we can use compare and conditional jump instruction together and increment decrement operation. These three we can combine together to implement the concept of a loop, or directly we can use this loop instruction. Okay, it is a shorthand notation. See, what we do not have to do here is we do not have to initialize, or we do not have to change the value of the counter. This decrement part, basically it is decrement. Okay, it is just starting from 3 and it is going down to 0. As soon as it becomes 0, the loop will stop. So this decrementing is automatically done. So whatever the way you feel like, you can write your code. Okay, guys, then hope you people have understood the concepts that I tried to explain you, and that much only in this part of the video. I'll see you guys with some new content in the next video. Till then, have a nice day.